How you doing, guys? Welcome to another video. We're still on topic 10, organic chemistry. This is volume 3 and we just look at reactions of alcohols. Let's get straight to it. Okay, so volume 3, reactions of alcohols. We look at oxidation of alcohols. I'll identify what an esterification reaction is, and then we look at combustion. We'll come back to esterification in another volume. So alcohols undergo what we call nucleophilic substitution reactions with acids, which is also called esterification, and some undergo oxidation reactions. We look at writing equations for combustion, writing equations for oxidation, and then we won't have time, but we will discuss condensation reactions as well. So alcohols contain the hydroxy functional group, which means they belong to the class of compounds called alkanols. Alcohols can undergo combustion reactions, oxidation, and esterification. Esterification is where they lose a water molecule, and we won't discuss that in this video. So a combustion of alcohols, we can use the same CHOD to help us balance a chemical reaction with a combustion reaction. So we balance for carbon first, hydrogen second, oxygen third, and then D stands for double if we have an odd number on both sides. So if we needed to write an equation for the complete combustion of ethanol, we would have ethanol as a liquid, that's its standard state, plus oxygen gas goes to carbon dioxide and water. Now, depending upon the conditions, the water could either be a liquid or a gas. If it's under standard conditions, it will be a liquid. If it's at different conditions, it could well be a gas. So liquid or gas would be acceptable here. So to balance this chemical equation, we balance for carbon first, so we put a 2 in front of the carbon dioxide. Balance for hydrogen second with the 3. That gives us 7 oxygens on the right, but there's 1 oxygen in the ethanol, so we just need 3 oxygens on the left. Referring back to a previous video, remember the different types of alcohols. We could have a primary alcohol, where the alcohol group is connected to a carbon that has 2 hydrogens. We could have a secondary alcohol where the alcohol group is connected to a carbon with 1 hydrogen, or we could have a tertiary alcohol where the alcohol group is connected to a carbon with no hydrogens. That gives us our different types: primary, secondary, and tertiary. Each one of these 3 different types of alcohols, they oxidize in a different fashion. Oxidize means we're adding in oxygen. So a primary alcohol oxidizes in a 2-step reaction where we add in an oxidizing agent, which is sometimes given a square brackets O, and our oxidizing agent is usually acidified potassium dichromate, which has the formula Cr2O7 2-. The potassium is just a spectator, so we don't need to write that as our conditions. We also need to apply heat for this reaction to turn a primary alcohol into an aldehyde. Once we've formed an aldehyde, then more oxidizing agent which is added, and the technique called reflux can turn our aldehyde into a carboxylic acid. So for our oxidation reaction, we need a number of things. We need our oxidizing agent and heating of our primary alcohol to form our aldehyde, which has the functional group C double bond O and then a single bond to a hydrogen. And then we need to add in more oxidizing agent and heat with a process called reflux to form the carboxylic acid. Now we know this reaction is taking place because the dichromate is a red color, and as it oxidizes, it forms a green Cr3+ ion. You can remember that as traffic lights going from red to orange to green. That's how you can see the reaction. A secondary alcohol only oxidizes in a 1-step fashion. It will only oxidize to a ketone. So a secondary alcohol, on the addition of the oxidizing agent, acidified potassium dichromate, and heated under reflux, will form a ketone. Tertiary alcohols are not oxidized by potassium dichromate. So for example, you would be asked to write an equation for the formation of either an aldehyde or an acid from a given alcohol. So in this one, we need to write the formation of ethanoic acid from ethanol. So we need to start with the formulas. Ethanol, CH3CH2OH. which is a primary alcohol. You could also draw this out as well, but I'm doing it in semi-structure. Now, it oxidizes in a two-step process. So I'm going to write in my conditions, H plus for acidified / dichromate, acidified potassium dichromate, our oxidizing agent. And then we would need to heat that to form the aldehyde. So the aldehyde will have the formula CH3CHO, and that would be called ethanol, al for the aldehyde. Then with further oxidizing, by adding more potassium dichromate, H plus, Cr2O7 2-, and heating with a technique called reflux, we could ensure that all of the aldehyde is converted to the acid. So in this case, it would be ethanoic acid that is produced. That would be our two-step reaction pathway for the oxidizing of ethanol to ethanoic acid. So in each step along this pathway, we could identify those reactions as oxidation reactions. The second one, write an equation for the formation of propanone from the secondary alcohol propan-2-ol. Remember, a secondary alcohol can only oxidize to a ketone. And the formula for propanone, in semi-structure it looks a little bit funny, but it would be CH3, CH, and then in brackets OH, and then we would have a CH3 at the end. I'm going to draw this one out just to make it a little bit clearer. So in full structural formula, I would have my carbons in their tetrahedral arrangement with my alcohol group sticking off the second carbon, my hydroxy functional group, and then at the other end I will have my CH3. Now, to get this to oxidize, we need to add in our oxidizing agent, acidified potassium dichromate, and to ensure that this turns from the alcohol to the ketone, we need to heat under reflux conditions. That will form our ketone, and our ketone has the functional group C double bond O. So we'd have CH3, C double bond O, CH3, which would be called propanone. So just to finish up, a secondary alcohol will oxidize to a ketone. A primary alcohol can be oxidized to an acid. So what about if I wanted to collect the intermediate product of the oxidizing of a primary alcohol, the aldehyde? That's the only part that I want. I don't want the acid and I don't want the alcohol anymore. I just want the aldehyde. So to do this, we use a process called distillation, which is where we can separate a mixture of chemicals from each other. So the way we would do this is we would have our ethanol and our oxidizing agent, acidified dichromate, in a distillation flask, and we would be heating that to get the reaction to go ahead because one of the conditions was oxidizing reagent and heat. Eventually, ethanol will start to form, but some parts of it might react more and we might also form some ethanoic acid. So the way we can separate these three chemicals is via their boiling point. They all have very different boiling points. So we set up our distillation apparatus, and what we would do is we would increase the temperature of the column until the top of the column was about 30 degrees. So that would mean the only compound that could make its way up the column and still be a gas as it reaches the top is the ethanol. All of the other components, the ethanol and the ethanoic acid, they wouldn't be hot enough, so they would drip back down into the flask. So we could collect our ethanol. Okay, well what about if I wanted just to collect my carboxylic acid? Well, if I wanted to collect just the carboxylic acid, I need to set up a reflux technique where we have our boiling flask and a condenser on the top, and we simply boil the mixture for an extended period of time. The mixture boils very rapidly, so there's lots of bubbling and there's lots of condensation of those gases and then dripping back down into the boiling flask. So to make sure that we've got all of the acid and none of the aldehyde, we reflux the alcohol for an extended period of time, and we make sure that we have an excess of the dichromate ions to ensure that all of the alcohol is transformed into the carboxylic acid. And this can take a fair bit of time. I remember one time at university I was asked to do this process and I had to sit looking at a fume cupboard for like 6 hours just to make sure my alcohol went to my acid. So some top tips for volume 3. Oxidizing of an acid or oxidation is using acidified dichromate. Its colour goes from red to green and you need to heat under reflux conditions to form the acid. Thanks for watching guys, don't forget, drop a like on the video, subscribe if you're new, and I'll see you